comment in there, Marquardt? Alright, let's warm it up. So hopefully you've all had a chance now to at least get the warm up done. Most of you have them done already. If not, just get those done right off the bat. Is there 5? Oh, 6 of them. 6. Yeah. Okay. Numbers. I know, because especially with exponents, they get ginormous really fast. You gonna make it there? You gonna make it? What'd you get for number? I almost said for number 1, but it's letter. What'd you get for letter A? 25, because really it means what? Yeah, exactly. It really means 5 times 5. And so we're going to say that that is 25. What? Up or down? Up? My up or your up? So you going to These are tough questions here, man. My up? Okay. Yeah, sir. What'd you get for B? 16, because what does it really mean? Times 2 times 2 times 2 times 2. 2 times 2 times 2 times 2. Yeah, 4 times. Yeah. Sometimes I gotta use my fingers to count out how many times what it really means. That's 16. Yes. Huh? Will, what did you simplify letter C to be?
X. That was an X squared.
Yep, exactly. X squared y cubed, or x to the 2nd power, y to the 3rd power. Right? X to the power of 2, y to the power of 3, or some crazy combination of any of those different ways. Yeah? Right. Left or right? Right? Okay. And what do we get for T? 9. Yep. Okay. 9. And then G. And then how many H's? So that would be H to the 5th power. Yep. Yep. Feeding it. Spoon feeding it. You know what I mean? Eric, what have you had that to? Would have you had that as an answer? Because I was looking at you, but all I said was that, but I said Edwin. Okay. You ready? What do we got for E? Okay, so that would simplify to be what? How many x's do we have? In total? 5 of them. So it would be x to the 5th power then, right? Yep. Love it. You want to do the A's down to the B's, or do you want to do it all? You want to do the A's? How many total A's do we have in the whole problem? Because right here, because this, so if we wrote this out, this one right here would be A times B, right? So I got 2 A's just right there. We'll check it again, okay? Because then here, this one would be A times A times A, B times B times B times B. So total A's, I've got 1, including one in a different color. I've got 1, 2, 3, 4, 5, right? Okay, so that would be a to the fifth power. Yep. And how many total b's do I have? B also b to the fifth power. Yep. Exactly. Questions on those 6? No? Nailed it? Okay. Before we go on, I want to ask, so kind of like what we did in letters A and B, and then we're going to kind of combine all this stuff. So if I have something along the lines of m to the fourth power. We've done a fourth power yet. M to the fourth power. Now, what does that mean? 4 times. So that really means, right? M times M times M times M. Right? Okay. Is everybody cool with that? Yeah? Okay? Because that's the basis for today. Okay? So now we've got x squared, then cubed. So what does that really mean, Austin? What am I going to multiply? How many times? So remember, we just got done saying that m to the fourth was m times m times m times m. So we multiplied m by itself 4 times. Okay? So if I've got x squared, then cubed, what am I going to multiply by itself and how many times? The x squared, right? I'm going to multiply this x squared here. I'm going to multiply this x squared by itself. Oops, I put 3 there. By itself 3 times. Right? Now, we can take that a step further, Michelle, right? Because what does x squared mean? If m to the fourth means m times m times m times m, what does x squared mean? Just this one right there. What does that mean? X times x, right? Okay? Now, really hard question. What does this x squared mean? X times x. And last hard question. What does this x squared mean? X times x. Okay? Dylan, how many total x's do we have now in this rainbow colored line? 6 of them. So we could write this as x to the 6th power, right? Yeah. Okay, we erase this. With me? Okay. Okay. Correct. Y cubed to the 4th power. This one right here. Y cubed to the 4th power. What am I going to multiply by itself and how many times? I'm going to multiply y cubed by itself 4 times, right? So that's going to be y cubed times y cubed times y cubed times y cubed. There's my 4 of them, right? Okay. Jake, what does each of those y cubes mean? So y times y times y? Okay. Okay. How many total y's are there? There's 12 total y's. We had a weird line. I was going to start with just straight lines, and then I was going to do curves, and then I got halfway in. Okay? Wyatt, yesterday in class, I talked about how in math there's always a pattern. Do you see a pattern? It's okay if you don't. Not everybody sees the pattern right off the start. No? Okay. Anybody see a pattern? What do you got, Tom? So these two numbers get multiplied? Is that what you're saying? Okay, I don't know what you're saying then. Okay, but I'm sorry, I should have been more clear what pattern we were looking for. Okay, I'm looking for a shortcut to go from the problem to the answer. So we don't have to write all this out all the time. What do you got, buddy? Of these? That was yesterday's pattern, yes. I want to go one step back. I want to go to this part right here. So I want to know what the pattern is to go from here to there. From here to there. What do you got? Multiply the two numbers. And what position are those two numbers in? Are they the base or are they the exponent? Yep. So the pattern is that we multiply the exponents, right? Will, is that what you were going to say too?
Yeah.
Okay. And this is the power of a power property. So when you're taking and when you have a base with an exponent to another exponent, okay? So it's got to have two layers of exponents. Sometimes you might see this written out as x to the m power to the n power, like that, and then that would be x to the m times n power. Okay? When you've got two layers of exponents, so you've got a base that's got an exponent, and then that's got an exponent to it. Yeah? So we multiply them. 2 times 3 here. If I multiply these two numbers together, that gets me my 6. 3 times 4 here. That's what multiplies together to give me my 12. Huh? Let's kick it up a notch. Oh yeah. Big time. Okay? Wyatt, we left off at June. Okay? If I've got xy and then I square that, what is the base that I'm multiplying and how many times by itself?
xy times 2.
So twice?
Yeah.
So xy times xy?
Yeah.
Yep. Okay. So then this is going to be, it's purple today, xy times xy. Agree? Okay. which, Chloe, that's x times y times x times y, right? Okay, so how could I... So how many x's do I have? 2 of them. So that's going to be x squared. How many y's do I have? 2. So that's going to be y squared. Right? Okay. Will n squared then q? What's my base? How many times am I going to multiply it by itself?
The base is MN squared. Or no,
Yep. Mn squared.
And then we're gonna multiply it.
3 times you said, right? No, I would agree with that. Yeah, sir. Mn squared means m times n times n, right? Each one. Okay. So this is m times n times n. This is m times n times n. This is m times n times n. Okay? So you asked her, how many total m's do we have? 3 of them. So that's going to be m to the 3rd power. How many total n's? 6 of them. So that's going to be n to the 6th power. Using our power to a power property that is literally right above it, now let's go power to a product property. Anybody notice a pattern? What do you got, Chloe? You're shaking your head yes. Well, what do you got? Throw it out there. See if it sticks. Nope. Okay. So let's relate it back to the last property that we had right above, right? That one we multiplied the exponents, right? But that was when we only had one thing inside the parentheses, right? Now we've got multiple things inside the parentheses. What do you think this property is going to tell us? What this property, so what, we'll go right to the property, we won't even look for the pattern. What this property is telling us is that the power, we'll jump down. I don't even want to say power. I want to say the exponent. I don't even want to say that. The outside exponent is applied to all parts inside the parentheses. Okay? So this 2 that was out here, this 2 gets applied to the y and it gets applied to the x. So it becomes x squared, y squared. This 3 over here gets applied to the m. That's why it becomes m cubed. And it gets applied to the n squared. And then power to a power, the one that's right above it, we multiply those exponents. That's why it's n to the 6th power there. Okay? If you forget these properties, What can you always do? If you forget these properties, what can you always do? You know what? We could look at our notes, but what did we do up here to find them? We wrote it out, right? Okay? So you can always write it out. Okay? Let's put it into work. Let's work we planned our work. Oh, we got powers of -1 first. Oh, man. Chloe, I saw you type it in on a calculator. What is -1 to the first power? Oh, you were typing that one in? Okay. -1 to the first power. Just -1, right? -1 times -1. We don't even need a calculator for this one, right? Because this means -1 times -1. What's -1 times -1? +1, right? Because negative times a negative is a positive. -1 cubed. No, it's not. It's what? No? So what does it mean? Austin, what does it mean first, before you give me the answer, what does it mean? Okay, so -1 times -1 is what, Austin? +1 times -1 is? -1. Remember, we don't multiply the exponent by the base, we take the base times itself that many times. Okay? -1 to the 4th power. Because it's -1 times -1 times -1 times -1, which gives me +1. -1 to the 5th power. We've heard them both. -1 times -1 is +1 times -1 is -1 times -1 is +1 times -1 is -1. -1 to the 6th. 1, 2, 3, 4, 5, 6. +1. -1 to the 7th. What's the pattern, Matcha? Or are you just spewing out numbers for me? That's 5, 6, 7. What do you got, Jake? So what about, so give me the evens first because it's the first line. Even powers of -1 are +1, so those all work out to be +1. Odd powers of -1 are -1. Okay? That's the only number that works for. That does not work for any other number other than -1. Doesn't even work for +1. Because for +1, the even powers are +1, and for odd powers, it's +1. Okay? The only number that works for is -1. Okay? All right, now, let's work our plan. CD cubed really means, CD cubed then squared, really means CD cubed times CD cubed. Right? Okay, we're up to you. How many C's do we have? 2 of them, so that's going to be C squared. How many D's do we have? 6 of them, right? Yeah, so I v to the 6th power. Again, if you need to write it out, we can write it out. One more, Brett? One more. Okay. Which one? You pick one. 6, 7, 8, 9, or 10. 7? Okay. So 7 is negative 2y to the 6th power. Right? So that's going to be what times itself 6 times? Negative 2y, right? So this is going to be negative 2y times negative 2y times negative 2y. That's 3. That's 4. That's 5. That's 6. Right? Okay? Now, can I show you a shortcut? Remember how we said in the power to a product that the power has to go into all of the parts, right? Okay? So this is going to be negative 2 to the 6th power. That's one of the parts, right? And this is going to be y to the 6th power, right? Now, for those of you typing in on your calculators, negative 2 to the 6th power, you have to be careful as to how you type it in, okay? Because it's an even power, right? So should the answer be positive or should the answer be negative? It should be positive because it's an even power. The powers of negative 1 told that. Even powers are always positive. Okay? But when you type it in your calculator, what do you get? What? You type it in a calculator because it's not negative 12. You can literally get up and go get one. That's what it sounds like you said. Doesn't matter. It's still not 12. Yeah. What do you get? You get negative 64, right? Okay. Anybody else get negative 64? Yeah? But we just said it had to be positive, right? Because it's an even number. So the keystrokes that you have to do in order to type this particular one in right here is you first have to open up a set of parentheses. Then you have to type in the negative key, then the 2 key, then you have to close that set of parentheses, then the caret, then the 6. Try that one once. Now what do you get? Now you get the positive 64 that we were looking for. Remember, Lacha, we don't multiply the exponent by the base. The exponent tells us how many times we multiply the base by itself. Okay? Stop doing that. That's bad maths. Okay? With me? You try the other 4 right now. You do the other 4. Is it you? Okay, what do you got for me in number 6? Yeah. But so you got 2 x's in your answer, right? Do I like that? No. Okay. So first off, my question to you is the 3 being controlled by an exponent? No. So that's just going to stay 3 then, right? Okay. Okay. So that's going to stay 3. And what can you tell me about these 2? Because there's no parentheses in this one. So, okay. And x, so how many total x's? 5. So it would be x to the fifth power. Yeah, exactly. Yes on number 6. That was the easy one. Okay? That was from yesterday. I shouldn't say easy. That one was from yesterday. Okay? Then, number 8. So if I follow this logic over here, I mean, I can totally write this out. I can totally write that out, and that's fine. Okay? But I could go negative 6 to the third power and h to the third power. Negative 6 to the third power. We'll go this way. Cora, what do you got? Negative 6 to the third power. Or negative 6 times negative 6 times negative 6. What kind of 216? Negative, because there's 3 of them, right? Okay. So that's going to be negative 216. And how many h's? 3 of them. And that's h cubed. Okay. On more complicated ones like number 9, yeah, sure, I can totally write this out. X to the m, y squared, z, x to the m, y squared, z, x to the m, y squared, z, x to the m, y squared, z. Totally can write it out, right? Okay. Or I can take each part. So this one part would be x to the m, and that's got to be taken to the 4th power. Y squared is the next part, and that's got to be taken to the 4th power. Z has to be taken to the 4th power. Okay? Now, from the other side of the sheet, when I take a power to a power, what do I do with those exponents? Other side of your sheet, literally you're turning your sheet over and you're looking in the middle for power to a power. What does it say to do? Jake, what does it say? Multiply the exponent. Okay? So Jake, what is 4 times m? 4m. So this is going to be x to the 4m power. Okay? Wyatt, power to a power, what do I do with them? Multiply them. 4 times 2? 8. So that's going to be y to the 8th power. Chloe, power to a power, what do I do? Multiply them. What's the power on z? What? What's the power on z? Right now, right here. Z to the 1st power? Right, but then you're one step ahead of me. I was pointing at this z right here. Okay, so then it becomes z to the 4th power. Yep. We were saying the same thing. You were just like a step ahead of me. Okay. Yes? Love it. What's the x is, I should say, in number 10, is the 3 being controlled by an exponent? No, it's not. Is the a to the 4th power at the end being controlled by another exponent other than the 4th? No. So those 2 aren't being controlled, so we could write them first. Right? So that's this one and this one. Then negative a is being taken to the 3rd power, and b squared is being taken to the 3rd power, because those are being controlled by an exponent. Correct? Okay. Negative a to the third power.
Oh.
Negative a to the third power. Anybody. Open for anybody. So what's negative a times negative a times negative a? Nope. Let's write it out then. So this would be negative a times negative a times negative a. How many a's do we have? We have 3 of them, right? So that's going to be a to what? To the third power, yes. Okay? Now negative times a negative. Positive times a negative. Negative. So this would be negative a cubed. No, actually weren't. B squared to the third power. Austin. Power to a power, what do we do? Multiply 3 times 2. 6, so this would be b to the 6th power. Right? Michelle, you're going to wrap this all up for us. You ready? Numbers. We deal with numbers first, right? So numbers right now, I've got 3 and negative 1 as numbers, right? 3 times negative 1 is negative 3. How many total A's do you see? Give up. 7, right? Because there's 4 of them here, and there's 3 more there, so that gives me a total of 7. How many B's do you have? 6 of them. Okay? Good stuff. If you haven't turned in K sub 2, not K, we're in K now. If you haven't turned in K sub 2, do that soon.